Hello, math students. Welcome to Module 1, Ratios and Proportional Relationships. This is Lesson 6, and it is called Unit Rate as the Constant of Proportionality. Our goal today, we are going to learn about the constant of proportionality. The question that I want you to be thinking about in the lesson is, what is another name for the constant in a proportional relationship? All right, things to learn. We're going to use a task to help us. We've been learning a lot about how to figure out if there is a proportional relationship within the information given. We learned in a table that if you have a constant number that the x value is multiplied by to get the y value, then that would give you a proportional relationship. And then we extended it on to the graph, and if you make your ordered pairs and it shows a straight line going through the origin, that is also a proportional relationship. So it will be very fun to see if this task is proportional or not. So the task says, wildlife scientists are studying the population of deer per square mile in our forests. In a 16 square mile area, there were 144 deer. In a 13 square mile area, there were 117 deer. In a 24 square mile area, there were 216 deer. Do you think the deer population is in danger? So I think the best way to figure out if it's in danger is if we can figure out if there's a constant, number one, and number two, we could figure out what the unit rate is so that we know if it's the same in each area. All right, so it says, let's check with a table and a graph. So I already have the table built. The only thing I didn't do was the unit rate, but I went ahead and put all of our values in. So we have, this is our input side. Remember that our input is usually the x value. This is our output side, and this is usually the y value. Remembering that the x value is independent, the y value is dependent, and this task actually helps a lot because deer depend on land in order to eat. They're vegetarians. So this is a great relationship thing that totally explains what dependent variables and our independent variables are. The deer depend on the land to have food. The land never depends on the deer because it doesn't matter. Grass is going to grow whether deer are present or not, but the deer actually depend on the land. So the land has to be the independent because it doesn't need anything to survive, whereas the deer has to be the dependent because they depend on the land. So that's a good relationship. All right, so let's try to figure out if we can see a constant here. So remembering the rules, if you have a constant, then you find the same amount that it is multiplied by in order to get your answer. So there are a couple things that we can check. If you remember, we did this pattern where we went 16 times blank gives us 144. Then we did 13 times blank gives us 117. 24 times blank gave me 216. 0 times blank gave me 0. And then it's also saying 1, but we don't know what 1 is yet, so we're going to try to figure that out. So the first thing that I would say that we need to do is we need to figure out what number times 16 makes 144, which the way you do that is you just take the number you're seeking and divide it by the number so that you can figure out what was multiplied to get it. So just looking at this, I know that 16 cannot go into 14, so now I have to start thinking about what is a number multiplied by 6 that has a 4 in the ones, and the one that comes to mind right away is 9, so let's try 9. 16 times 9 is 54. 9 times 1 is 9, plus 5, 10, 11, 12, 13, 14. Aha, there it is, kiddos. So this is a 9. So that's 9. Okay, so now let's do 117 divided by 13, and let's just try just to see if 9 is a constant. So let's go 13 times 9, and we get 7. That's 9, 10, 11. Aha, it is. Check it out. So that's 9 also. So that one's 9. So now let's see if 216 divided by 24 could be 9. So now we're going to take 24 times 9. 36, 3, that's 18, 19, 20, 21. Kiddos, it is! Awesome! So this is 9, and then 0 times 9 gives you 0, and then we can go ahead and do it. 1 times 9 equals 9, so this would be a 9 here. All right, so this answers my question. We do have a constant. We found it. So that's a good thing. Okay, so hooray, hooray. So then our next step is we are supposed to make our ordered pairs, remember? So we have 16, 144. This is going to be a huge graph. 13, 117. 24, 216. 0, 0, and 1, 9. Wow, that's a huge graph. Okay, now you guys are saying, why does she keep saying that? Well, I say it is because we have to show 144 up here. We have to show 117 up here. We have to show 216 up here. We have to show 0 up here, and we have to show 9 up here. So that's a really big spread for a graph. Okay, so let's do the x's first. We always know that's 0. And then we have a 1, a 13, a 16, and a 24. So I'm thinking that because we know that graphs have to go in order, they have to have intervals, that what if we went ahead and counted by, let's do 2s. So this would be a 2, a 4, a 6, an 8, a 10, a 12, 14, 16, 18, 20, 22, 24. Haha, that one just worked. Okay. Now we need a 9, a 117, a 144, and a 216. You know what? This is super crazy. What if we counted by 20s? So it would be 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 100, or 220, 240. Well, that would cover it. Okay, so let's do 20s. I wonder if 10 would. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 120. Nope. It's going to have to be 20s. Okay, so 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240. Okay. Phew, do you see why it's a huge spread? Okay, then this, the words, even though you can't see it through all my mess, should say square miles, and this should say deer. Okay, we're getting closer. All right, now let's graph, kiddos. First one says 16, 144. So here's 16, and then 144. Well, this is 140, and 150 is in half, so we're going to say 144 is about here. Okay, then we have 13. Well, this is 12 and 14, so 13 is right in the middle. 13 and 117. So there's 100, there's 20. 115 is in the middle, so we're going to say 117 is about there. Okay. Now it's 24 and 216. Well, that's 220, which is too high. That's 200. So that would be 210, and it's supposed to be 216. So I would say about there. And then 0 and 0. Okay. And then 1 and 9. So 1 is here. 10 is halfway, so 9 has to be about there. All right, guys, let's get my ID and see if we can connect them and make a straight line. This is going to be pushing it. I need a ruler, but I don't have a ruler here. I do, it's just downstairs. Okay, so let's see if we can get this to work. So here, here, and here. All All right, so we were a little off on that one. We'll just make the dot a little bit bigger so that they pass through, because we already proved they were proportional, right? So we'll just make our dots bigger so they actually pass through. All right, looks like it's going to work. So did we go through the origin? Check. Did we have a constant? Yes, it was times 9. And is it a straight line? Yes. So the question is it proportional? Yes, it is. But the question said, do you think the deer population is in danger? So that means in every 1 square mile, there's 9 deer. I don't think it's in danger. I think it's okay. The fact that you have 9 deer in 1 square mile, all you need is 2. And as long as they're the opposite sex of each other, then they're going to make new deer. So I think having 9 in a square mile is probably a good thing. Okay, so I don't think it's in danger. So good job on that one. That was a lot of work, but it was fun to figure out. Okay, so let's go back over here and just read over some information that's really important that you understand. Ratio tables and graphs are made of independent and dependent variables. So the thing I want you to add to that is the independent is known as the x, and the dependent is known as the y. The independent is the input, and the dependent is the output, so that's very important. Independents are items that can exist without any other item. They are known as the x value. The dependent variables are items that only exist with the independent item. They are known as the y value. The constant is the amount that is multiplied to the x every time. The unit rate is determined by always dividing the y by the x value. So in order to find unit rate, you take y divided by x. How do you find unit rate? Y divided by x. Y divided by x. How do you find unit rate? Y divided by x. How do you find unit rate? Y divided by x. How do you find unit rate? Y divided by x. So the last thing that you need to know, and this will answer your question from the beginning of the lesson, the constant and the unit rate are the same exact thing. So if you find your per 1 information, have you found the constant? The answer is yes. So you just learned something really powerful, kiddos. The constant and the unit rate are the exact same value. Okay? So it's really important that you remember that. Okay, let's go back over here really quickly. Today we are going to learn about the constant of proportionality. What is another name for the constant in a proportional relationship? You better remember because I just told you. All right, kiddos, make sure you have option 1 or option 2 finished, and I will see you all tomorrow. Bye!